In this lesson, we will learn a new technique, tail call optimization. It can greatly improve the efficiency of recursion programs and completely prevent stack overflow caused by recursion. This is the program we use to show you how tail call optimization works. You probably have noticed two places that are different than usual. In the outer function, I have turned on the strict mode and changed the browser from Chrome to Safari. This is because tail call optimization requires the strict mode and is currently only supported by Safari. Chrome does not support it yet. Node.js supported it temporarily and have removed it from the current version. In the future, tail call optimization will definitely gain mainstream support. Despite the lack of browser support, tail call optimization is a very commonly seen topic in job interviews, so you should still learn how to use it. The outer function calls the inner function from inside itself. So the outer function will be pushed into the stack first. After the first console log statement has been executed, the inner function will be pushed into the stack. At this moment, the execution of the outer function is not completed yet, so we will have two functions in the stack at the same time. In other words, the stack now has two frames in it. The stack space is not infinite. Old frames should be popped out as soon as possible. If we choose to invoke the inner function at the very end of the outer function, then by the time the inner function is invoked, the execution of the outer function has already completed. There is no need to keep it in the stack anymore. The tail call optimization will pop the outer function out of the stack before pushing in the inner function. This can guarantee that at any given time, the stack only has 1 or 0 frame in it. As a result, stack overflow is prevented for good. To enable the tail call optimization, we need to meet 3 requirements. First, the outer function needs to be in the strict mode. Second, the invocation of the inner function must be placed at the very end of the outer function and must be returned. The last requirement is there must be no data reliance between the inner and outer function. The inner function must be able to work without relying on the outer function at all. It cannot reference any data that is defined in the scope of the outer function. Otherwise, the outer function won't be popped out. But sending a primitive value into the inner function as argument value is fine. Now, after the second console log statement has been executed, and before the inner function gets pushed into the stack, the outer function will be popped out of the stack by tail call optimization. As a result, the stack will have no more than 1 frame in it at any time.